Hello everyone, it's me Uncle John. Today I am going to read S4 4086 Climate Change by Barnaby Newbold. Chapter 1. What is climate change? The Earth is very old. It has changed often during its long life, and it is still changing. Millions of years ago, when dinosaurs like Tyrannosaurus rex were alive, the earth was much warmer. There was very little ice on the land or on the sea, even in the very north or the very south of the world. And the sea was very much higher than it is today. There have been many changes since that time, sometimes to a warmer climate, sometimes to a colder one. About 20,000 years ago, for example, a time called an ice age began. There was ice over much of the world, and it was 3 kilometers deep over much of North America and Europe. And the sea was not as high as it is today. Our climate has changed many times, and it will change again. Why does our climate change? Sometimes the change comes from outside the Earth. For example, the Earth moves around the Sun. This is called the Earth's orbit. Every few thousand years, the Earth changes its orbit around the Sun. Change happens slowly, and it brings the Earth near to the Sun, or it takes it far away from the Sun. When this happens, it can finish an ice age, or it can start a new one. Changes can also come from inside the Earth. An example of this is the volcano of Krakatoa. When it erupted in 1883, the sky became dark over many countries and stayed dark for months. And then for more than a year, the earth was 1 degree Celsius colder than before. But now, for the very first time, people are changing the climate. In the year 1900, the earth was 0.7 degrees Celsius colder than it was in 2000. Just 100 years later, this change did not happen because of the Earth's orbit. It happened because of us. Some people think that this is a small change, but think about this. A change of just 5 to 7 degrees Celsius can start or finish an ice age. Does climate change happen quickly or slowly? The film The Day After Tomorrow is about a change that happens very quickly. In the film, the Earth's climate changes in only a few days, and a new ice age begins in the north of the world. Can the climate change like this? Scientists think that it can, but not as quickly as this. Scientists think that it can, but not as quickly as this. Scientists do not always agree. Some think that the climate is changing a lot, and some think that it is changing a little. Some think that it will change quickly, and some slowly. But all scientists agree that climate change is happening. The important question is this: how dangerous will the change be? Al Gore, who worked next to President Clinton of the USA between 1993 and 2001, thinks that the change will be dangerous. In his film, An Inconvenient Truth, Al Gore describes how the Earth's climate has changed. He has talked about the dangers of climate change for more than 20 years. But is he right? Is climate change a dangerous problem? Must we do something about it? And what can we do? Chapter 2. How does our climate work? Why can people live on the Earth but not on Mars or Venus? The answer is all around us. Our atmosphere. Our atmosphere is made of gases that are necessary for life. Two most important gases are nitrogen and oxygen. The other 2% of our atmosphere is made of many other gases, and the most important of these gases for climate is carbon dioxide. Our atmosphere is important because it gives us air, and we need air to live. but it has another important job. Because of our atmosphere, the Earth does not get too hot or too cold. Mars has a thin atmosphere, and its temperature is about minus 50 degrees Celsius. Venus has a thick atmosphere, and its temperature is about 460 degrees Celsius. The atmosphere of the Earth is somewhere between the two. 200 years ago in France, a scientist called Joseph Fourier had some questions about the sun and the earth. When the sun shines, the earth becomes hot. But what happens at night? He asked himself, when the sun is not shining, why does the earth not lose its heat? In his garden, Fourier had a greenhouse, and he put young plants in it because the air was warmer. He thought that the Earth's atmosphere was like the glass of a greenhouse. Warm air stays in a greenhouse because of the glass, and warm air stays on the earth because of the atmosphere. You know much more about the atmosphere now than Joseph Fourier knew, but we still use his words, the greenhouse effect, today. So why does the earth not become cold? How does the greenhouse effect work? Light from the sun comes to the Earth's atmosphere and heats the Earth, but this heat is different from the sun's light. Not all of this heat from the Earth can go back through the atmosphere and escape into space. There are some gases in our atmosphere that stop the heat from escaping into space. That's why these gases are called greenhouse gases. The most important of them is CO2, which stays in the atmosphere for 100 years, much longer than any other greenhouse gas. But what stops the hot places in the world from getting hotter and hotter? Why do the cold places not get colder and colder? To answer this question, we must learn a little about the sea. The water in the oceans moves around the world like a river. Warm water travels to cold places in the world and makes them warmer, and cold water travels to warm places and makes them cooler. Because there is so much water in the sea, this can make big changes to our climate. Famous example is the Gulf Stream. In the North Atlantic, the Gulf Stream carries warm water northeast from the Gulf of Mexico to Britain, Ireland, and Scandinavia. The Gulf Stream brings heat to Europe. It carries 50 times more heat than all the houses, all the offices, and all the factories in the world. When the water of the Gulf Stream gets to Iceland in the north, the water becomes cold. Cold water is heavier than warm water. So the cold water goes down under the warm water and it goes back south. This is what happens now. But what happens when something changes? In the next chapter, we will look at some of the changes that are happening to our atmosphere and to our seas. And we will look at the greenhouse gas, CO2. Chapter 3, Getting Warmer. We do not know everything about our climate or about climate change, but we do know two things. The earth is getting warmer and we are putting more CO2 into our atmosphere every day. How do we know about these changes? In 1896, a Swedish scientist, Svante Arrhenius, was the first person to measure the effect of CO2 on the climate. From 1300 to 1850, the climate of Europe was much colder than it is today. But when Arrhenius was writing, the climate was changing. Europe was coming out of the Little Ice Age. Arrhenius was interested in this, and he thought that it was because of CO2 in the atmosphere. If there is less CO2, Arminius said the atmosphere will become colder, and if there is more CO2, it will become warmer. At the time, people in Europe were building more factories. The factories were burning coal, sending more CO2 into the atmosphere. Arrhenius made new measurements. If there is 100% more CO2, he said, the atmosphere will become 5 degrees Celsius warmer. Arrhenius was nearly right. Today, most scientists think that if there is 100% more CO2, the atmosphere will become 1.5 to 4.5 degrees Celsius warmer. But Arrhenius thought that this would happen in 2,000 years' time. And scientists today think that it will happen in the next 50 years. Why do they think this? What is really happening? In 1958, a scientist called Charles Keeling decided to measure the CO2 in our atmosphere. He needed a place that was far from towns and factories. He went to Hawaii, to the top of a mountain called Mauna Loa, and he started to measure CO2. His measurements showed that every year there is more CO2. CO2 in our atmosphere has increased every year for the last 50 years. But we can look back in time much earlier than this. Scientists can now measure the Earth's atmosphere many thousands of years ago. To do this, they cut deep holes into the ice of Antarctica and Greenland. They take out a long, thin piece of ice. This is called an ice core. The ice at the bottom of the ice core is made from snow that fell a long time ago. When the snow froze and became ice, air stayed inside the snow. Scientists can measure the CO2 inside this air in the ice. All this ice comes from a hole at a place called Dome C in Antarctica that is 3,270 meters deep. The ice at the bottom of this hole came from snow that fell more than 800,000 years ago. From this ice core, we know that there is more CO2 in our atmosphere today than at any time in the last 800,000 years. And we know that in the last 100 years, the CO2 in our atmosphere has increased by more than 30%. A colder climate brings an ice age, but a warmer climate has the opposite effect. And this is what is happening now. The ice is melting all over the world. Ice in the glaciers of the European mountains, called the Alps, has been there for more than 20,000 years. But the ice in these big frozen rivers is melting. And these glaciers are now half as big as they were in 1900. In Tanzania, Africa, there is 80% less snow and ice on Mount Kilimanjaro than there was in 1900. And it will all melt by 2020. The Baoshi Glacier, number 1 on Mount Yulong in China, 6% smaller than it was in 1850. And in Bolivia, South America, the Chacaltaya Glacier has 80% less ice than it had in the 1980s. But some of the biggest and most important changes are happening in the Arctic. Winters in Alaska and the west of Canada are nearly 4 degrees Celsius warmer than in the 50s. And in the summer, the change is even bigger. In the summer of 2007, there was 20% less ice covering the Arctic than in the 70s. In other words, the Arctic has lost a piece of ice as big as the country of Egypt. Less ice covers both the island and the sea, and the ice on the snow is now less thick than it used to be by nearly 40%. What will happen if more ice melts? This problem worries many people all over the world. But before we look at this problem, we must first look at some of the changes that have already happened to our climate. Wetter and drier. The earth is getting warmer and much of the earth's ice is melting. This new water is going into the sea and the sea level is getting higher. These changes are happening now and they will bring many problems for the future. But other changes are happening that bring immediate danger to people all over the world. Change is happening to the world's rain, where rain falls or doesn't fall, and how much rain falls. Too much rain means a danger of floods. Too little rain means a danger of drought. When there is a flood or a drought, there is less clean water to drink, and people die. In this chapter, we shall look at some of these immediate problems. The sea covers 70% of the earth. Seawater is salty, and you cannot drink it. Only 3% of all the water on the earth is fresh without salt. And most of the fresh water is frozen in the ice of the Arctic, the Antarctic, and the world's mountain. We need water to drink, but we also need water to grow food. To grow a kilo of rice, you need about 2,000 liters of water. And for animal, like sheep and cows, you need about 10,000 liters per kilo. Each person on the earth needs at least 1.7 million liters of water each year. Each year, the number of people on earth increases. So there is nothing more important to us than rain. Where does the rain come from? And is there more rain or less rain than before? Rain comes from water in the sea and rivers, and also from water that's in the land. This water evaporates in the heat of the sun and makes water vapor, very small drops of water in the air. The water vapor goes up into the atmosphere and gets colder, and the little drops of water make clouds. When the clouds go up higher, they get colder, and the little drops of water get bigger. The drops of rain fall, putting water back into rivers, lakes, the sea, and the land. This is called the water cycle. Here's an example. In India, the weather is at its hottest in May. The air over the land becomes much hotter than the air over the sea. The hot air goes up very quickly. This pulls in more air from the sea. This air, which carries water vapor from the sea, becomes a strong wind called a monsoon. As the monsoon goes over the land, it brings heavy rains across India. Farmers need these rains to grow food. No rain means no food, but too much rain at one time means flood. On the afternoon of 26 July 2005, Anjali Krishnan was driving to a business meeting in Mumbai. It started to rain and the traffic had to stop. She waited for 10 hours. The rain didn't stop and she had to leave her car and try to walk home. The water in the streets of Mumbai came up to her neck and it carried empty cars and dead cows past her. It took her 2 hours to get home. She was lucky because her home was still there. But many people were less lucky. On that day, there was nearly 1 meter of rain and it continued for a week. More than 50,000 people lost their homes in the floods and 1,000 people died. In the past, when the climate was less warm, the monsoon rains were not so heavy. But now, with the warmer climate, there are more heavy storms in each monsoon. Scientists think that the monsoon rains will increase by more than 10% during the 21st century. Perhaps there will be some years with a little rain, but there will be more years with heavy rain and floods. And this is true for other places in the world. For many people, the 21st century will bring more rain, heavier rain, and more floods. But many places in the world have the opposite problem. For them, a hotter world is a drier world. The Sahel region of Africa is south of the Great Dry Sahara Desert. In this region, there is less rain than before, and one of the biggest lakes in the world has nearly disappeared. Lake Chad has lost 95% of its water. This has happened in only 40 years. So climate change is not simple. Different changes happening in different places, but one thing is changing for everyone. The weather is making more problems. When it is hot, it's going to be hotter than before. When the wind blows, the wind will be stronger. When it rains, the rain will be heavier. In other words, the 21st century will bring us extreme weather. Finish the part A.